All right. This video is going to be on, or this lecture is going to be on 4.1, Intro to Fractions and Mixed Numbers. So when we look at a fraction, 3/4 as an example, top number is your numerator, bottom number is your denominator. All right. The types of fractions. So we have a proper fraction in which, let me write it this way. Sorry for the handwriting, trying to write the best I can on the screen. Numerator is less than denominator. Okay, so proper fraction is when the numerator is less than the denominator. So an example of that is 2/5 or that 3/4 that I had initially. An improper fraction is when the numerator is greater than the denominator. Go 10/7. Numerator is greater, top number is greater than the bottom number. And then mixed number. All right, so a mixed number is going to be the sum of or a combination of, depending on which wording you like to use, sum of a whole number and a proper fraction. So make sure you keep in mind that your fraction, if it's actually going to be a mixed number, this fraction right here has to be a proper fraction. In other words, the numerator has to be less than the denominator. Your whole number is right here. Then you have a proper fraction that's attached to it. All right. So one of the first examples in this section. So write a fraction for the shaded portion. And another F look jacked up, but we'll be all right. So let's see. All right, so the way we go about doing this, we have our top number. When we look at our fraction, top number will be the shaded pieces. The bottom number is how many pieces it takes to make a whole shape. I know it's a longer statement, but when we go through the example, you see what I mean. So on top, we have 3 shaded pieces. On bottom, how many pieces does it take to make this whole shape? And that would be 5. And that's your answer, 3/5. All right. Let's say if I had this type of problem. All right. So this one, the top is probably going to be the easiest part of this exercise. Say how many pieces are shaded. We got 1, 2, 3, 4, 5, 6, 7 pieces are shaded. Then how many pieces does it take to make a whole shape? Now keep in mind, this is a whole shape. So it only takes 3 pieces to make a whole shape. So it's 7/3. Now the other way of writing this is by using the mixed number option, wherein how many whole pieces or whole shapes are shaded. And it would actually be 2. And then we look at this one separately as our fraction, 1/3. So that's 2 whole pieces, or not pieces, 2 whole shapes are shaded. And then 1/3 of a shape is shaded. So those are the 2 different ways you could express the shading of this exercise. All right. Let's look at another example. Well, type of exercise. Let's go from convert mixed number to improper fraction. All right. First step, apply. All right. So converting mixed numbers to an improper fraction. First thing we're going to do is multiply the whole number to the denominator. You're going to add the result to the numerator and then keep the same. I didn't write that good at all. Keep the same denominator. All right, let's see. Let's go with 7 1/4 as our mixed number. We want to convert it to an improper fraction. So I'll go 7 times 4 plus 1. And I keep that same denominator. I'm going to multiply 7 times the denominator, which is 4, and add it to the numerator, which is 1. So 7 times 4 is 28. 28 plus 1 is 29. So it'll be 29/4. If I have 8 2/5, let's say if I have -8 2/5. That negative is not a part of this process. It just stays on the outside. So you got 8 times 5 plus 2. And like I said, that negative is just sitting on the outside. So that 8 times 5 is 40. 40 plus 2 is 42 over 5. So it's negative 42 over 5. All right. So let's go in reverse. Let's convert an improper fraction to a mixed number. All right. Divide by long division. All right. So that quotient, you're going to write the quotient as your whole number. In other words, that's your answer part. And you'll see what I mean in a second. Your remainder is what's left. That's going to be your new numerator, and you're going to keep the same denominator. That's what's left, and this is your same denominator. All right, so let's try that out. So let's look at 25 over 6. So the first thing we want to do is divide by using long division. Then we're going to write it accordingly. So set up your long division. Let me make myself some more room than that. Set up your long division process. 6 doesn't go into 2, but it goes into 25 4 times. 6 times 24. 6 times 4, excuse me, is 24. And 25 minus 24 is 1. So this is your remainder. This is your quotient. That's the answer part that I was talking about. So the way you will write this is 4. That's your quotient. Remainder is 1, and then you keep the same denominator, which is 6. And remember, you can always check because you can take this back by using the process that we talked about before. Okay, so I had a little snare in here. Hopefully my video saved. If not, I have to redo this one anyway. So let's go from here. So we did 25 over 6. And let's do another one. We have 39 over 4. So the first thing we'll do is set up our long division process. 4 goes into 39. 9 times. 9 times 4 is 36. 39 minus 36 is 3. So our answer is 4, not 4, excuse me, 9 3/4. All right. And then in this section, they emphasize one last thing of just absolute value, which we talked about last section. Absolute value of -2/7 is 2/7. Absolute value of 1/5 is 1/5. Absolute value of -4/9 is -4/9, but don't forget that this minus sign or negative sign is not affected by the absolute value, so it's still sitting outside. So that'll still be -4/9. And then if you have parentheses instead of absolute value, negative to a negative turns positive. That couldn't happen with your absolute value because the absolute value had to be applied first. So negative to a negative turns positive. We have 4/9. All right. I think that is it for this section. Oh, one more thing. Generically, just we look at the properties of fractions. Anything over 1 is itself. So 5 over 1 is 5. 100 over 1 is 100. 0 over anything is 0. So 0 over 5 is 0. 100 over, not 100 over. 0 over 100 is also 0. Anything over 0 is undefined. Anything over 0 is undefined. Anything over itself is 1. And negative over negative is positive. Negative in front, negative on top, or negative in the bottom are all the same thing. So if I have -3/4 over -3/4, that's a positive 3/4. Or if I have negative sitting out front, -3/4 or 3 over -4, all of those equal to the same exact thing. All right, so hopefully this video is good enough. Like I said, I had a little hiccup in the middle. Hopefully I was able to save it. If not, then I'll just have to redo this anyway. All right, have a good one.